Hey everyone, thank you so much for coming to my presentation. This is going to be on creating rubber duckies. That's a cute rubber ducky up there. And my name is Madeline Kaye, but everybody calls me Snacks. I'm a GRC analyst, and I do want to start doing bug bounties in about the next 5 years. So I try to be as technical as I can be. I'm a GRC analyst because it just kind of works out well with my personality and with the kind of career that I'm aiming towards. So I'm really excited about that. I'm also an instructor at 801 Labs. I kind of started as a presenter, but we are going to be doing some more regimented classes in the future. So if you haven't heard of 801 Labs, check us out. It's pretty awesome. It's a hacker space is what we call it, but honestly, it's just a bunch of people who really love technology, cybersecurity, coding, all that, and they just kind of show up to like answer questions and kind of share what they already know. So if you haven't checked them out, check them out. And we're local in Utah, so it's going to be a fun time. I believe that's my LinkedIn QR code up there. So feel free to add me on LinkedIn. I'm also on Discord as Snacks, and it's going to be a good time. Just reach out if you have any questions. Before we get started, I know that you're going to run into some problems. You're going to run into some issues. If you have any questions or anything like that, this is a very good link for you. Menti or Mentimeter, whichever you call it or whichever you know it by. This is actually kind of anonymous so that you don't actually have to put in any kind of like, PII or anything like that as you're trying to participate and interact with me. So if you just go ahead and enter that code in at menti.com, or if you just scan that QR code, it'll work. If you're way in the back, zoom in and then it'll kind of recognize the QR code. But this is going to be a good way for you to like send me the questions and then like as they come up, and then towards the end, I can actually just see what questions you guys have and we can take it from there. Okay. So what's in it for you, right? You guys are all here because you want to create rubber duckies. The reason why I went with these particular 8Tiny85 ones is because these are very cheap and they're designed to be legal. The code is designed to be legal. I have a background in the legal field, so I didn't want to actually introduce a code to you guys that could be used in like malicious ways. So this is a fun legal way, And this is going to be your first Arduino project for a lot of people. If you guys have already worked with Arduinos before, you're all set. If not, this is a really good gateway into using Arduino for other projects. Honestly, the first time I did this, it was a Cyber Mentor video on YouTube. And Heath Adams, if anybody knows him from TCM Security, he did a video on the $2 rubber ducky. And that's how I got started into all of this. And it was very exciting. He knows what he's talking about, and that was a rabbit hole. So I've it's been fun so far. Okay, so I do have to put this disclaimer up there just in case. So stay safe, have fun, make sure that we can continue to provide more technical stuff like this, more technical code. Just all in all, don't get me nervous, please. But if you have any questions, if you want to continue learning, I'm here for any questions. So let me know. The agenda is we're going to get into 8Tiny85 boards, Arduinos. We're going to talk a little bit about what each of these actually are. And then you're going to design your own rubber ducky. And then towards the end, we're going to do a little bit of a Q&A. But with that being said, you guys have the link. If you need the link again, let me know. But it's going to be a really good way for you to actually like interact with me through the code that I provided. That way I can just kind of have them all up there. If we run out of time on the Q&A, I can actually just maybe reach out to you on Discord or something. We'll talk about it. I'll be here afterwards. Okay, let's get started. So this is the model that we're actually going to be talking about today. This is going to be the 8Tiny85 dev board. There is a USB-C version of it. I did play around with it a little bit, but this one is the most common one. And this was the most reliable one for me. And usually when people say 8Tiny85, they mean the chip itself that sits on top of that. So let me see if I can actually point to it. Okay, there we go. That's the chip over there. For people who are viewing this online, it's right there. I could have just actually done this from the get-go, but here we are. So this is the actual 8Tiny85 chip. So you're going to see some details on there. If you need the technical details, I have charts. But the majority of people here, I just assume you guys want to like get started with the fun. So we're going to skip all the details. but I do have multiple charts. So let me know if you're interested. Okay, so what does ATtiny85 actually stands for, right? So the AT part of it, it refers to Atmel. Atmel was the original company that kind of developed the microcontroller family, but they've been bought and sold a few times. So the designation is AT, and that's just kind of stayed with the products. The tiny part of it, there's a lot more info to get into, right? But like, as I'm giving you these like keywords and stuff, feel free to Google them. But when I say it's a rabbit hole, I'm not joking. There's a lot to learn with this. And depending on who you are, it's fun to know these details, right? So the tiny part of it is the tiny AVR, like that's what it refers to. So there's different sizes of them. There's, I think the other one is mega AVR. But the 8 is 8 kilobytes of flash memory, but actually with the way that we're using it, it's more like 6. So that shouldn't change anything that you upload on here. We're not going to go into that advanced of a code where we have to worry about how much, we're working with here, but just a little FYI, just throwing little nerdy tidbits here and there, Okay. Oh yeah, I forgot the 5. 5 is just the model number. So you're going to see a lot of ATtiny85 products. There are so many of them. So let's see. I want to make sure I haven't missed anything. Okay, we are good. I want to kind of talk about what happens from when you plug in the USB to, and I'm sorry, I'm just going to refer to these things as like just a USB. I don't want to say ATtiny85 every single time because, my stutter is going to show up at some point. So when you're plugging in this USB, pretty much, this rubber ducky, if you're programming it, it's going to kind of show you what how the different pieces help you when you're programming the actual board. And the bottom are when you're actually running the rubber ducky. So the reason why I have this on there is because if any of you guys, let's say you rewatch this like 2 years from now and you actually want to kind of get more advanced with it, or even after this presentation, you're like, what else can I do with it? How can I do more with this besides what you've just, beyond what you just told us? You can actually kind of focus on the board manager. And because this is not an actual Arduino board, a lot of this stuff is third party. So you have to make sure that the pieces kind of fit together properly so that this actually functions through Arduino IDE, right? And I'm hoping that as I'm saying this, I'm hoping that you guys are actually downloading the Arduino stuff. If not, go ahead and open it. This is a very hands-on kind of presentation. We are actually going to get into the code itself. So there's that. It kind of helps out, but pretty much if you are wanting to customize this a little bit more, you're going to want to learn more about the board manager and what it does. You're going to want to learn about the code library and what it does. And then there's a whole bunch of resources that I can point you to, or I can even share with you about different types of USB, different modes of USB. So a lot of times, so with this, right, this actually the computer identifies this as a USB. And then it goes into run mode. So certain people are like, well, what if I don't want it to actually run as USB first and then go into run mode, right? What if I can just plug it in and it just works, right? What if the computer doesn't even consider this a USB at any point? Well, at that point, you have to look at the bootloader. You have to make sure that the bootloader that you're using is actually compatible with this version, with this chip. And then from there, you want to make sure that the code that you put on here is what you want it to be. Because if you make it so that the computer doesn't even recognize it as a USB, you can't edit the code on here. So just kind of keep that in mind. But yeah, board manager, code library, bootloader, those are some of the stuff that you're going to want to look at. At the bottom, we're going to see that the code just loops as well as at the top, because the kind of code that we have on this Arduino IDE kind of UI, I guess, it's going to run in a loop. So the key for me is just making sure that there are enough delays so that it doesn't just loop around too quickly, pretty much. But there's a little bit of a pause, but we'll get into it later. This is taken from Arduino's website. I actually really love their official website. By the way, I would like to take a moment and thank every single person who contributed to all the questions, whether they asked a question or, answered a question or any kind of help that they provided on GitHub, Reddit, on Arduino forums everywhere. Figuring this out on Windows 11 was a feat. So I really just appreciate anybody that contributes to any of these forums. It's great help. So, okay. If you've never used Arduino, sorry guys, I lost my mouse for a second. If you've never used Arduino, these are the basics that you should know. We're not going to get into all of it, but I just wanted to highlight some of the important parts of it. Verify and upload, right? Every single time you have code, how do you upload it, right? First, you have to verify it. Arduino IDE kind of runs through it and says, okay, this code looks good. You can proceed. And then you're going to click. So this is going to be verified, that little check mark towards the top left-hand side. And then that little arrow, that's going to be the upload one. So you're going to press that, and then it's going to say, I'm ready, plug in the USB, and then you'll plug it in. The other parts that we're going to look at are board manager and library manager. The rest of it, you could get into it. We could talk about it after a presentation, but I only have a limited amount of time, and I didn't want to get into this too much. So with that being said, like I've said a million times already, I'm here to collaborate. So just let me know if you have any questions. Let's set up your rubber ducky. My biggest recommendation for you is to make sure that you're actually following along with our speed. There are certain portions of this that if you move too quickly on and you're not really familiar with some of the tools we're using, you could actually damage some of the components that you have. So yeah, if you don't have a rubber ducky, sit back. This is going to be on YouTube. But if you do have a rubber ducky, feel free to follow along. And if you run into any issues or have any questions along the way, or maybe even suggestions, maybe you notice something and you're like, hey, it's going to be more efficient if you do it this way, please feel free to just post that for me on that Menti link, and I'll be happy to take a look at it. Okay, the requirements for this, the way that we're setting up these codes, you're going to want admin rights on there. So the UAC thing is going to pop up, and either enter in your password or just click on agree or accept or yes or whatever the default one is. And then we're going to use a tool called Zadig. This is a third-party tool, and this is the tool that's a little bit dangerous. Dangerous in the sense that if you've never used it before, what it does is it actually replaces the drivers on your USB. So your camera, right? That's got a driver. Your mouse, that's got a driver. So if you don't actually know how to use Zadig and you go and you download it and try to rush forward, what you could do is actually just uninstall the drivers for your cameras, for your integrated camera, or even like replace or delete the driver for your mouse, for example, right? Even the integrated mouse and keyboard parts of it. So just be ready on that one. Arduino IDE, you're going to need that downloaded. And then let me see where I actually put this one. Okay. Sorry, you guys, there are so many wires here. You're going to need a USB 2.0 adapter. A lot of the newer laptops, they have 3.0 or newer versions of the USB. So I just kind of bought a cheap little adapter that's 2.0. A USB hub or even an adapter that's like 2.0 USB. Sometimes you could program these on the 3.0 ports, but they sometimes run into an issue. From what I've seen, if I'm running them on a 3.0, there are no issues. But if I'm trying to program them on a 3.0, sometimes the computer doesn't recognize them. So if you're running into any issues, maybe try a hub or an adapter or something, and that should fix it. Or honestly, I love that these come in a pack because sometimes one of them just is defective. So I can just use one of the other ones that came in the pack. Okay. So I'm just going to go ahead and move forward with this. Somebody give me a look or something to kind of let me know if I'm going too fast. I won't be able to slow down too much on this. I do want to make sure everyone gets up and running, but just kind of like nod at me or something, and then I will know if I'm going too fast. So please let me know. Okay, so go on Arduino.cc, and then you can even just go to Google and just type in Arduino IDE download, and then you'd be set. For this one, because this is a Windows computer, I did want to mention this code doesn't particularly run on Linux. I'll explain why. But everything that I'm talking about here, this is a Windows-oriented kind of presentation. So I just downloaded the regular default one. If you do need any legacy Arduino IDEs, for example, like let's say this one, the 2.3.6 doesn't actually work on your computer or you're running into any issues, try the legacy ones. And that's going to be actually, if you go to the actual page and scroll down, it's going to be like somewhere right there. Also, that's where you can find the Linux ones as well. So the Linux packages and all that stuff. Okay. You were going to install it. We're going to wait eternity for it. And then from here, we're going to go. I do have Arduino pulled up. I want to refer to these as much as I can. But if you guys need clarification, I'll be happy to go into my Arduino program and actually show you guys where to click and everything. But I think these are descriptive enough. So the first step is you're going to want to go to File and then Preferences. And then that's going to be towards the top left-hand side. So if your Arduino, for whatever reason, if you can't find this or if it doesn't show up like that, just nod or something and I'll acknowledge you. Okay. So we're going to go to Preferences. We're going to add a board manager. The board manager pretty much, like I said, because this is a third-party kind of hardware, it's not Arduino-made hardware, you're going to want to add a board manager that kind of defines some of the functionality that this needs. So for example, the board manager is going to tell this one how to talk to the computer and what it's supposed to do. And there's a whole lot that goes into it. We're not going to really get too complicated with it. You do want to be very granular with the details as you get more advanced on this and as you're trying to invent new functionalities on this. But we're just going to be using stock code. So, okay, so this is the board manager that I've been using. I did want to also give a disclaimer that if you're like a little paranoid about security for a good reason, you don't have to download any of this. You don't have to participate with any of this. Be safe. I'm comfortable using all of this stuff because I have a burner laptop. So I'm a little paranoid to say the least. So just stay safe out there, right? If there's any doubt in your mind or if you're just uncomfortable going and downloading these packages and whatnot, just enjoy the presentation and then we can talk about other options because there are other board managers you could be downloading. So for preferences, honestly, once you open your preferences pop-up, that one, that's just the default one. It just pops up. You could change it. Depending on the project, I do change it. For this one, this was just a screenshot, so I didn't really change it. The theme, if you're going to be staring at your computer for a while, you do want the dark theme. Because I'm presenting, the light theme looks a lot better. So that's why I chose light. Language, of course, and then show verbose output during compile and upload. You are going to want to check these if you run into any problems. And I'll show you guys how that could be helpful. But let's say right now, don't check them. But then later on, if you run into any problems or error messages that it displays for you, you do want to come back in here, make sure those two are checked, and then go back and run your code again. And then it'll give you a lot more detail about how to troubleshoot it and what the error actually is, Compiler warnings, I've never had to really use them. You could have them, I usually just pick verify code after upload, which we're going to do anyway. So even if it's not automatic, we're going to do that anyway. And autosave just because nobody wants to lose their progress. And then I just usually add the board manager URL. And that's where I leave it. So depending on what I'm working on, for like something like this is like a level 1 thing, is how I would put it. So just literally, you just change 3 things and that's it. Okay, the next thing is we're going to be adding one of these board managers. So the board manager that I was using, that I've been using, is the DigiStump AVR boards. And the version 1.6.7 worked for me, so yay for that. By the way, for any of these ones, any of the codes that I'm sharing with you, I've tried it on 3 different laptops. So I've kind of based the presentation off of what worked in most of the scenarios, if not all of the scenarios. With that being said, you do have the option to change the version that you're downloading. So if you're running into any problems, it'll help to try a different version and see if you're still running into issues. We'll talk about that more towards the end. Right now, we're going to focus on the fun stuff. Later on, we're going to actually go through how to troubleshoot stuff. Okay, the next thing we want to add is the ATtiny core. And this is by Spence Condi. I don't know how to say it. He's very active on GitHub, which I appreciate as well. So with this one, though, the latest one, I believe it was 1.5 point something something. That one didn't work for me. So when I was trying to download this one, and please ignore the top one. I didn't want to white it out, but please ignore the top one. That's not part of the presentation. For this one, I did have to change the version to 1.3.3. That's the one that worked really well for me. So once it's installing successfully, you're going to see this just towards the bottom right-hand side of your Arduino page. And if we have time, I will actually run through all of this just as if I'm creating a new rubber ducky, just so we can run through this together. But I did this for the sake of time to make sure that we get through all the whole presentation. Okay, so now we're going to have to pretty much tell Arduino, we're pretty much going to have to tell it what this is, right? So for that, you're going to want to go through and select the board manager, and then it's just go up here and do board. In ATtiny core, if you go in there, certain ones do have like the ATtiny 85 something something micronucleus something something, or they have ATtiny 85 Optiplex. You could use those if you're going to be using ATtiny core. I have both of them just for testing, but I prefer the DigiStump one. That's DigiStump AVR boards, and then it's just DigiSpark. I did want to point out a very important thing that a lot of people get hung up on. The port here, it's grayed out, right? If it's grayed out for you, no worries. We'll still run the code, and it's likely going to work because of all the tests that I've ran, and I ran through 30 of these just to make sure that I'm catching the errors as they come up. It's a numbers game, The port has never shown up. Even when I tried this a few years ago when it was hip, it still did not come up. So what I was looking at is on a lot of these forums, people are actually concerned that, oh, I can't select the port. It's not coming up there. I don't know what to do. So don't worry about that too much. We're still going to be able to upload the code, and I can guarantee that to a certain degree if you follow everything that I'm telling you here. Now we're going to get to the fun stuff. This is the part where I said if you move too quickly, you could actually replace or delete one of the drivers that you have. So just let's move at a steady pace. You're going to go to Zadig, and that's going to be the official link for it. This is based off of a GitHub, an open source project on GitHub. So feel free to follow the documentation on there to GitHub and then read through literally everything. And it's very helpful. So you can actually go through it and look that up. But for our purposes, we're going to go in here. And this website, he's got a bunch of ads on there. So kind of be careful what you're clicking on. My recommendation is just click on the one that says Zadig 2.9. There is a download button. I didn't click on it. But even when you click on this, there's a little pop-up that comes up. Just exit out of the advertisement, exit out of the ad. So yeah, so there's that one on there. And then this is... nothing has to really install. The tool just downloads and you can just run it. So yay for that. Once it's actually open, you are not going to be able to see any details on any part of it because it's just everything is going to be blank, right? It's going to say, here's the driver. Oh, wait, it's blank. Or here's the USB ID, but it's blank, Don't worry about that. Go up there to options and click on list all devices. Now you're actually going to see what has a driver on your device. Now, digital bootloader, that's the one that we do want to select. That's the one that we can ensure is not a camera, is not a keyboard, is not a mouse, or whatever else. All the cool stuff that you have connected to your computer. And then this is the USB ID for all of these DigiSpark ones. This is something that I have a chart on. So like I said, if you're interested about learning more about IDs, learning more about the modes, and how the computer even identifies these and runs through them and works with the USBs, it's pretty fun. Just let me know if you want any other charts. We're not going to go into that here, so don't worry. You want to make sure that you select DigiSpark bootloader, whatever that says, it doesn't really matter too much for, for our purposes. You don't want to select this. Make sure that you're switching it over to that. And by using this was able to run on Windows 11. This was able to run on ports 3.0. That one is fantastic. And there are limited drivers that you could download from the internet, and there are limited drivers that you could use this tool to replace. So what you want to make sure is just use that, and then that worked in literally every scenario that I ran into an error on. It's going to say installing driver. Sometimes it'll take 5 minutes. I didn't actually time it because it was just way too quick. So yeah. So if it takes a little bit of time, just give it a little bit of time, but it is pretty quick. And then if you go into advanced mode, which I'll be happy to show you, if you go into advanced mode, you can actually see every single thing that it's doing to process your request. So we're not going to get into that here, like I said, but I'm just letting you know about the fun features, There are so many people that are, that are here and that are going to be watching it online. So if you want to dive more into it, I'm just letting you know where you can find each one. Once it successfully installs, then you're good to go. If you go into device manager, it is going to say this. So sometimes, we don't want it to say this, right? You might even have to go at the very top of the device manager, like towards the top toolbar, and you want to look at the hidden ones. And then you might want to delete the ones that say unknown USB device, right? If you delete these and run through the Zadig process again, sometimes it kind of pushes the code through and it works and it replaces driver and you're good to go. But if you don't delete the ones that are like hidden, then somehow it like messes up the code. And see, this is the kind of stuff that I would love to know more about. So if any of you guys want to reach out to me, just volunteer information, I would absolutely take it because I love the background processes that happen. Once it looks good, ignore this part of it, right? Once it looks good, it's going to kind of say that, yep, it installed successfully, it's good to go, and this is what it's going to say on here, right? So once you see that, you're pretty much good to go, honestly, but there are other signs you could be looking at. Now we're going to apply the code that you want for the tool. And so on my GitHub, I actually have a ducks in a row repository. And so in there, you can actually see two, let's see, one of them is the Wi-Fi saved emails. I forgot what I actually named it. I can pull that up as well. But one of the tools that I have the code for up there is actually going to be kind of showing you how to like get the Wi-Fi passwords to the saved networks that you have. So the reason why I said this is completely legal is because there's no way you can use this in a malicious way. So if you're like, let's say if there's a network and you don't know the password to, this tool is not going to help you get the password for it. It's just going to display the passwords that you've already saved in here. So it's going to be more convenience kind of thing. It's not going to be really used for pen testing or anything like that. But I did want to show you how to create this. That way you could use this for literally any project. We are doing good on time, so I think we are going to be able to run through a demo if everything goes well. So yeah, feel free to go on there. There's one for that, and then the other one is a Rickroll, so yay for that. Just literally copy the entire code that's in that, like whichever you pick, just go ahead and copy the entire code and then go in Arduino. And I usually do just Control A and then replace everything in there. And then we are going to be verifying it. We are going to be uploading it and it's going to look good. Let me actually run up here to kind of show you guys. Okay. So once you have all of the code here replaced, you could click on verify. Don't plug in your... I'm so sorry, I forgot to mention. When you're doing the Zadig stuff, you might have to use the adapter or the USB hub that's 2.0. And at that point, you do want the USB plugged in, of course, so that you can select it, you can replace the driver, all that fun stuff. But when you actually get to uploading the code on here, if it's currently plugged in, Arduino's not gonna recognize it. So what you want to do is just unplug it and then verify the code and then click on upload. And then it's going to say at the very bottom, there's like a black area and it's going to say blah, blah, blah. Like plug in board now or something to that effect, and that's when you can actually plug in the board. Once it is just, sorry guys, it's so light here. I can't see where I'm clicking. once you're actually done with it and once you're actually successful, then it's going to kind of look like this. It's going to say done uploading at the very bottom, and it's going to say micronucleus done. Thank you. So let's go ahead. We are doing great on time. We're actually going to run through this. Let's see which code I have up. Okay. Saved Wi-Fi passwords. And then that's not the one I want. Sorry, guys. Let me pull up the actual one that I want, and then we'll go through it. Okay, I can either do the Rickroll, or I could show you guys the saved Wi-Fi passwords one. Let's do, just raise your hands. Who votes for a Rickroll? Who wants to see me create a Rickroll rubber ducky? Okay. You guys have a good sense of humor. How about saved Wi-Fi passwords? Oh, okay. It's still fun. We'll give it a little love later. It's still a fun one. So let's do the Rickroll one. Okay. Now, I am cheating a little by having my code already in there, but let's pretend that I just let me actually run through the whole entire thing with you, just in case anybody ran into any problems. Okay. All right. So this is my Arduino. It's not going to look like that at the beginning. It's going to look more something like this. Void setup, void loop, right? Setup kind of tells it how to set up the board itself. The loop part of it is the actual code that you want to run. And as the name implies, it just runs and runs. So the way that I counteracted the looping so that it doesn't get too problematic is at the bottom of my code, I put delays and everything like that. You could put the delays to be as high or as low as you want, right? But as you're setting up your code, if you're going to start doing your own coding, right? Not just copy and pasting the code. As you start doing these, you do want to put certain delays in there just to make sure that it's not starting to type before a process has ended. If you do that, and I have actually a problematic one that I can show you, if you do that, it's going to just type it before the process is ready. So for example, it is going to open command prompt, but what it's going to do is it's going to just type in 3 of the letters instead of the whole thing that I wanted to type. So if that happens, if you're like, oh, it's the Digi keyboard that's causing a problem, it's not typing what it needs to, then at that point, just, switch the delay to 400. This is the one part that I'm not geeking about too much because honestly, with the delays, you could see at the bottom here, I'm not really creating a science based around this. I'm just creating delays. And these ones, I think if I remember, I forgot how to convert these to how many seconds these actually become. There is a video on there. I'm so sorry. I totally forgot that part of it. But usually my comfort zone is around 300, 400. You're not even going to notice it at that point. It's just going to run as it's supposed to, and it's not going to be too much of a delay. But the reason why, and I heard that, antivirus software and everything, or some IDSs and stuff, look at user behavior. If you have a code like this and you just plug it into a computer, it might get tagged and it might say, wait, a person can't type that fast, or this person can't type that fast. So let's kind of review this. What's going on here? Is this a script that's being run, or what's going on, right? So in order to avoid that, sometimes you want the delays in there to be able to run the tool without it being discovered. There's a lot more science to it, like I said. But if you go down the rabbit hole, you will find all of it. If not, let's talk. I'll be happy to do another class on this. Okay. I have my delay error one. Let's actually run this. Okay. And I'm going to actually put it into one of the 2 cases that I have printed for these. I don't know if this one is going to show up on camera because all of this is just black, but Please ignore that. Okay. So on here, I don't know if this actually shows, but this is the little case for it. And this is through printables, so I didn't really alter the STL file too much. It's just through printables, pretty convenient. And then if you just type in 80tiny85 rubber ducky, you can find so many different cases for it. The other one has 2 parts, and these 2 parts just clip together, and you know, you can put your USB in there, and this looks literally like, I don't know if you guys can see it, but this looks literally like a regular USB. So if you want to use any of that, they're right up here at the first table, and then they actually make life a lot more convenient. Especially these ones, you could actually write on there. You could put a label on there if you have a label maker or something, because you're going to be getting so many of these, hopefully, that you are going to lose track of what each of them do. You could plug each one into test, but honestly, who wants to do that? Okay. Let's see. All right, so I'm going to plug in my faulty one. And this one, the delay is not set properly, so it tries to run too fast. And that's what happens. It doesn't type it because the process didn't finish before the typing thing kicked in. And the funny thing is, as many times as you enter this in, the more stuff pops up. So that's very fun. That's very interesting. And so if you're like caught in a loop and you're just consistently, you're like, it's not doing what it should be, what's going on, just look at other parts of it, right? Don't repeat the same thing. You know, that's just insanity. So the part here that's problematic, sorry, I didn't mean to do that. The part here that's problematic is that over here it says LAN, right? So the code for this, as you can see on my GitHub, it should say VLAN or like WLAN, like, you know, not the VLAN one, but it says WLAN, and that didn't get typed after the process was finished. So as the process had just barely finished, that's when this thing started typing. So it didn't obviously type the whole thing. At this point, if someone's trying to plug this into my computer, I will catch them, obviously, because my, you know, the scary black screen is going to come up and I'm going to call IT and I'm going to say, what's happening? And then, you know, that's what's going to happen. Let's see. Okay. We are still running good on time, but I did want to point out certain things with this. Because once you click it in there, let's actually program this one. Sorry, you guys, this is a little bit of a setup. I didn't realize we would be going through this so quickly. This is fun. I was hoping that I would get to do a demo. Okay. So here's what we're going to do. You're going to go in here. You're going to go to preferences. Oh, I'm sorry. That's a different one. This is a different computer. Add the first link that I mentioned in there. So you're going to add that link in there. And then I have all the stuff in there just in case. And then you're going to want to go to tools. And then with the board, the G-Stump AVR boards, select the default one. And then if that doesn't work, you could go through the ATtiny Core one. Okay, ATtiny 45 /80, /85 OptiBoot. That one sometimes works. I ran into some problems with it because it interferes with the board manager. So once I have those two things configured, I'm going to want to make sure the library is good. So what was it? DigiStump. These are DigiSpark boards. And DigiStump kind of stopped. Oh, it's not on there. Let me review it. This is why I have the screenshots. With DigiStump, the bugs haven't been fixed. So that's why there are so many issues with this. And like I said, these ones were popular a few years ago. So the hardware hasn't really been updated or anything like that. You might run into a lot more luck just by getting the chip itself and then mounting that onto a board. But I'll still run through this. Let's see if this one actually works on here. First, I'm going to put in the problematic one. And I'm going to show you that it doesn't recognize it. It's fine. This is the broken one, so I do want to actually reprogram it. Okay, so upload, and the thing is already plugged in, so it just says plug in device now, but it's already actually plugged in. So at this point, I can just honestly just replug it. And then you get 60 seconds, but once this is done, it says micronucleus done. And then, oh, right. I am so sorry, you guys. I didn't actually edit the code before I put that on there. But the good thing is that you could... I'll troubleshoot this later. But this is what happens. This is the life of testing these out. There are so many varieties of it. The screenshots that I put in there, those are a lot more reliable. With this one, I haven't actually tested on this burner laptop, because obviously I wouldn't connect it to my home Wi-Fi network, so that's why it's a little wonky. But follow the screenshots, because those are tested and true. Let's see. Okay, I did want to point out this part of it. As you can see, this is just supposed to open the Rickroll video on YouTube. You could make it open any single URL. So literally, if you replace that part with any URL, it'll open. And the way that this works, as you just saw, is it just opens the run box. And then from the run box, it enters cmd/Kaye mode. And then from there, once that opens, it just starts running the other stuff, like the start max Chrome. And start just says start Chrome, but make it full screen because it's more annoying that way, especially if it's a Rickroll. So literally any code that you can enter into command prompt, you could actually program on Arduino. So with these different alterations, you could get it working on Windows 11. It's been a lot more reliable on Windows 10 because around the time that these were popular, Windows 10 was the thing, you know, but with Windows 11, it seems like a lot of the creators just kind of stopped working on it, stopped, like, you know, contributing or committing changes to bug fixes. Let me try to actually upload this one more time. And then if anything, I'll just plug in the one that's supposed to work. I know you guys can't see it, but I have a button here that turns this on or off. So I don't turn it on unless... What? I don't turn it on unless it's ready for it. Here. Let me double check this code. It literally worked before the presentation. This is what happens when I'm doing a demo. I try to get a video going, but I use the game thing. Okay, see? It's just running into an issue. It's the delay. I tried to get a demo going, but it was literally just recording everything except the command prompt screen. And so all it was looking is like I was just browsing the internet, and it wasn't even capturing the command prompt stuff that I was doing. So this is what happens when we do a live demo. Okay. Thank you. Yeah, we fixed it. I'm sorry it doesn't show up on here because I actually have the audio. There we go. I have that in there. Let's see if it works again. But you kind of just saw the little insanity that goes into programming these and troubleshooting these. Oh, sorry, you guys. Oh, okay, the audio, that's okay. That's okay. You guys already, I'm sure this is playing in your head. You can already hear it. Yeah. But yeah, this is a pretty fun little prank. So, Anything else that, like I said, anything you can do in PowerShell, you could program that in here, because literally anything that you can program into that little run box, you could make that thing do that in Arduino IDE. So keep playing with it. I think we are out of time. Okay. And so with the Q&A and everything, I'll be hanging out a little bit. If you have any questions, let me know. But thank you guys for attending. I hope you have a good conference. Thanks. Here you go.